Welcome and good evening. We from Group 11 will present to you about instruments that can be used to detect marine pollution. So let's go.
I will explain about the GCFID. GCFID means the gas chromatography flame ionization detection for detect the oil spill in our ocean. Basically, this instrument has a two phase between which is a mobile phase and stationary phase. Okay, so in a mobile phase, we have a carrier gas which is helium to carry the injection samples to analyze, while in stationary phase, we have a columns and oven, and column divided by 2, which is a packed column and capillary column. First of all, we need to inject the water sample using a small string into injector, and it will vaporize immediately in a hot injector, and the vapor will travel down to the column with an inert gas. Vaporized chamber heat until 50 degrees Celsius above the boiling point of the water samples, and that's why it vaporizes immediately. Okay, at the end of the columns, the most volatile component will spend more time in a vapor phase, while the least volatile component will spend more time in a liquid phase, and it's stuck in the columns. Okay, it shows the most volatile component traveling faster than the least volatile component. End of the column is provide a quantitative measurement of component of mixture as they dilute in combination with a carrier gas. Detection of ion formation during the combustion of organic compound in a flame will generate by the hydrogen and oxygen. To detect the ion, 2 electrons was be used, which is negative and positive, to provide a potential difference. In the last part, it relates to the computer and a software. The detector will generate a signal and convert it into a chromatogram. When the samples is detected, it shows a peak with respect to the retention of time of the sample. The under of the peak shows the information of the concentration of a sample. If the concentration less, area under the peak is less.
This is FPIR. It stands for Prism Transform Infrared Spectrometer. It is used to identify chemical using infrared light to measure absorption. How does FTIR work? First, place the sample in the FTIR spectrometer. The spectrometer directs beams of infrared at the sample. The instrument measures which wavelengths are absorbed. The computer takes the raw absorption data and conducts a math process known as Fourier transform to generate a readable absorbance spectrum. This spectrum then can be compared to a library of spectra to find a match. It can use to identify unknown material, additive in polymer, surface contamination in materials, oxidation, and decomposition. There are 3 advantages of using FTIR spectrometer. The first one is accurate identification of compounds. The second one is analysis with little or no harm to the sample. The last one is sample information is collected accurately and at high speed.
AAS is an analytical technique to estimate various atoms by the measurement of light energy of specific wavelength. AAS can measure the trace amount of metals in a faster way with high accuracy and sensitivity. AAS was found to have a wide range of applications in the various important areas, which include in marine environment. AAS is used for the determination of metal concentration in waters from oceans. AAS method can be applied for the determination of iron, cadmium, lead, nickel, copper in seawater samples. Modern instrumentation of AAS typically consists of a light source called a hollow cathode lamp, a detection system, an atom cell, and a computer system to control instrument operation, collect data, and process data. The principle of AAS. When a beam of electromagnetic radiation passes through a substance, the radiation may either be absorbed or transmitted depending on the wavelength of the radiation. The absorption of radiation would bring an increase in the energy of the molecule. How does it work? The radiation from the source is directed by a mirror on the sample. The radiation then passes through an analyzer, which selects the frequency reaching at the detector at any given time. The signal from the detector passes to a recorder which attached to the analyzer to produce a trace of the absorbance of varying frequencies.
So how does HPLC work? This is a schematic overview of the HPLC. The solvent is needed to create a mobile phase. The mobile phase is needed to transport the samples through the HPLC system. To create the mobile phase, we need a pump. The pump moves the solvent continuously from the flask to the waste can. To measure samples, an injection system is needed to inject the samples into the mobile phase. The identification and quantification of the components happens in the column. As we can see, the sample is in the mobile phase. So when the sample reaches the column, it leaves the mobile phase and enters the stationary phase. The stationary phase is the substance fixed in place for the chromatography procedure. This is where separation takes place. After leaving the stationary phase, the sample moves through a detector. The detector sends the signals to a software on the computer which converts it in a chromatogram. The fundamental principle of HPLC is separation between mobile phase and stationary phase. HPLC is used to detect marine oil spills. Besides that, environmental contaminants such as the presence of pesticides, petroleum residues, and many other substances designated as conventional pollutants.
Okay, so hello and assalamualaikum. My name is Muhammad Nazrin, and today I want to talk about the instrument that I've chose to trace pollution, which is ICP-MS. So ICP-MS is a mass spectrometry that uses an inductively coupled plasma to analyze the sample. So it can trace heavy metal pollution at low concentration. So the fundamental principle is it atomize the sample and create atomic and polyatomic ion, which are then following the several procedures before being detected. So how it works? So the procedure on how it works is firstly sample were introduced into the plasma aerosol droplet. So plasma drives the aerosol and atomize and ionize the sample. As positively charged ion are being drawn into the sampler cone, hyperschema cone and schema cone, and then arrive at the quadrupole ion deflector. So at the quadrupole ion deflector, analyte ions are being beamed into the universal cell, while photon and neutron ion are being discarded. So in the universal cell, there are three different modes, which is first standard mode, second collision mode, and third reaction mode. The standard mode is like a non-cell instrument, while the collision mode uses non-reactive gas, where the smaller analytes ions is being separated by the large interfering polyatomic ions. So reaction mode use highly reactive gas targeting interfering ions and remove it, as it also being held by the kinetic energy discrimination or KED for the efficiently output. So when it's arrived at the detector with 9 order of dynamic range, it's being detected. And lastly, you can see the data can be seen in the software on your computer. So that's how ICP-MS work. And thank you.